Yeah, there you go. And I need to go back and edit some of those videos now because I need to put the topics that they focus on there for some of them. All right, there you go. So that's taken care of. And let's send a link here. Invite some persons here. Oh, wrong thing missing. All right, let's just send this out. All right, and then there's also the link. All right, there you go. All right, so that's taken care of now, guys. And so when object is in equilibrium, the sum of some clockwise moments about any point is equal to the sum of anti-clockwise moments about the same point. All right, let's hold that for a second here. So, like somebody just find this pan there, what on book or something. That's a lazy question, this one. All right, so after reading that now, where you must go here? The sum of the
Clockwise or anti-clockwise, anyone.
Anyone? Mm-hmm. All right, I don't know what's happening here. So yeah, let me just make sure this pen is up and running. Yeah. So it's a clockwise here, and all right. So the clockwise about any point. All right, is equal to the sum of the anti or which other clockwise?
Counter.
Yes, or counter. About the same point. That's it. That's why I get 4 marks now because you write points. You write point 2 times, same word. That's a hint though. I don't know. It would have been, to me. It looked like it would have unfair to some students. Or at least the student that did this one, they would have to be in that mood. And remember, physics is people use them. Is a what you call now? You call it a left brain subject where your math and the reasoning side more alert in a physics exam. So it's like, for example, doing an English exam is a different feel in your brain than when you're doing a maths exam. Anybody ever experienced that?
Yes, sir.
Yeah, it's at a different type of energy, different type of stress there. So when you're doing these questions now in physics where you have to go right out and so no, it's for some students it can be an issue here. Maybe reading the psychology of it too deep, but I know as a student, I know how I would work here. So this might be unfortunate though, but notice that so far there's no calculation. No calculation. So far. 4 marks. No calculation. So what's happening? Well, you know that we don't probably reach here yet. Physics is not physics without little maths in it. So everybody good with this part, right?
Yes, sir.
Yes, sir.
All right, good. So let's go on to part 2 now. Apart from the seesaw, and I like how them start here. Apart from the seesaw, because they go to something specific. Apart from the seesaw, identify 2 situations in which a force would result in a turning effect. So, all right, seesaw is like an example now. What other things now would have a turning effect? You know?
when you apply the force for your spanner to rotate a nut or pull a nut.
All right. All right. So yeah, you could take that approach. You could take that approach.
Force.
What else?
Applying force to a doorknob and
Doorknob, turning
swinging
a
it door
doorknob,
open.
door and hinge. Yeah. All right. Those could work. Those could work.
A
Yes, go.
cyclist,
What's that?
a cyclist hung his bicycle on
Yeah.
like a hook.
Hanging a bicycle. I tell you what, those situations are I want to say they are the same, you know. What you're really telling me.
Or a
no more.
wheelbarrow.
Wheelbarrow is a nice one too. However, they are all the way just tell me they are related, you know. They come under one heading. One single heading there. It's a pity CXC take it off of the syllabus. But all the way you're telling me is what you call a lever. Everybody ever hear about lever before?
Yes, sir.
Yes.
Yes, sir.
Yeah, all right. So then that would be from even PIP or GSAT. You know, you hear about lever, you know. All the way just tell me door opening and so on, you know, crowbar and well, nobody said crowbar, but I think Benita said spanner and nut. Yeah, definitely all those would be the same example. So yeah, any two. So two situations. Let's write spanner and nut. But then we would classify it as a lever. Why is this not writing? Oh, I think, yeah, that's better. So lever. And those of you who remember learning about levers back then, if not, and the CXE syllabus no, but then, you know, you have 3 classes of lever, 3 types of lever. All right. So, all right, so situations there. Opening a door. In fact, that's actually a lever, you know. Another is pointing to a lever. Seesaw is actually a lever, and I think Jenner said a wheelbarrow. And that's also that's actually a lever, you know. They could get more specific there in terms of a class.
And what about the cyclist, sir? Hanging his bicycle. Like a hook.
Yeah. A bicycle that's hung.
Like in tights, sir, or something. And lift up.
Yeah. All right. No. And on a single wheel. All right. So all of these would be what you're expecting here. All right. So these are your answers. No. What if I were doing this paper? What would I write? All right. Since I said seesaw, they could have other answers there. No, turning a force that results in a turning effect. We could also say use of into a pulley. So all of these would be acceptable, and we know what should know what a pulley is. In fact, a pulley is really a lever that can rotate 360 degrees. So use of
when you pull one side down, sir.
Yeah. What the is all right. Turning effect. Yeah. You could say torque and wheels. Because this turning effect. So you have a wheel that's round, and then each time you do stuff on the top of the wheel rotate. That's a turning effect too. So so these are other examples or situations where a force is applied, where a force results in a turning effect. All right. So in an example, cars would have this example. So yeah, this is open-ended, guys. So I mean, anything goes here. You can't get anything wrong here once you give something sensible. All right, so we can move on from this. Any questions here?
No, sir.
Okay.
No, sir.
All right, good. So oh yeah, definitely. All right, in terms of simple machines though, to go over them, you have the inclined plane, the wheel and axle. I suppose you could say, yeah, you can say crowbar and nail as well. Looking at all of the questions that so the example like this with the bike suspended, this CXC sent a question with that, CXC sent a question with wheelbarrow already. I remember this clearly 2008. This was the year when this was the year when I left college. So I remember 2008 there when actually this was certainly the first CXC paper I would have seen there. Wheelbarrow. This is 2008. The bike question I think came in 2006, somewhere there. Opening a door, I don't see that. Spanner and nut, I haven't seen a question about the crowbar. Them saying a crowbar question. Everybody know what a crowbar look like?
Yes, sir.
Yes, sir.
Sir.
Right.
You have one edge curve and one near end curve.
Mm-hmm. So let's look at it. For those of you who don't know what a crowbar is, let's bring it up on the screen so you see it, where the turning effect is applied here. In fact, this is Jamaican show where a guy in the
Home Alone.
oh yeah, crowbar, yeah. Home Alone. Oh god. Home Alone. Certainly.
I think two, either 2 or 3, sir. One of them.
Oh, you watch all of them.
Yes, sir. Watch all of them.
It's part 1.
But one, oh, can these people arguing over Home Alone? All right, yeah, definitely. I like this. This is good. This is good. There's an explanation for the crowbar, so let me just give it here. In case you guys having problems here. Everybody seeing this?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. So a crowbar would be good example here. Returning effect is where the force is applied here, and the load goes up the other way. So there's a turning effect here. See the turning effect. All right. So that's the crowbar principle here, principle of moments being applied here. All right. Somebody was saying that which should have one them saying. Oh, 1 year them send one question with a waiter holding a tray. Which year was that? No, that was one of the early, I think one of the 90s question too, you know. Waiter holding a tray, and then the tray was like the finger was like the pivot, so the tray would be having the weight there, and the person arm would be like the load. So, or was it? No, the force would be the arm. The force would be the arm. So, yeah, as we say, I'm CXC find all kind of something ask the question there, and look out for that. I mean, they would use real life things and make it a thing as one of the questions. But the indication from what I'm seeing now is that them all cut the Hooke's law question short and drop in a moment of a force question there. Again, the main reason they will do things like that is that they they want the exam to cover as many objectives in the syllabus as possible. All right, so that's what they are going after. So that's how them do it. All right, so and then worse like how if the graph ever come from Hooke's law, no, then them will just say, all right, Hooke's law, I'll give them 7 marks, probably ask one couple questions for read the graph, find the original length of the spring or whatever they use, and then work out probably the same thing we work out last class with the mass of the object and thing. Those would probably add up to 7 and say 5. 7 and 5 would that be 12. Them can easily go back now and ask a moments question where value the other 13. So it should be interesting to see how CXC send a question with those 2 topics together, seeing that there are different topics. So, but look out for that though, guys. They will get creative. CXC will get creative for June exams. All right, so the example. So this is where so it's an example of a force. Benita, drop off. A force causing a turning effect. All right, so there you go. Crowbar at work. All right, so going for this question, part 1, principal moment state, that part 3, 2. Let's look at the other part of the question. No. Everybody seeing this?
Yes, sir.
All right, so now let me give some common names. You're supposed to know. Kyle and Kian. It's almost look like a Barbados names. And you know anybody named Kyle in Jamaica?
Yes, sir.
Yeah. Popular name, popular enough in Jamaica. Anybody named Kian?
Yes, sir.
Really?
So
Okay.
I'm look over there, Kiani, one twin.
Okay, got those modern names. All right. So Kyle and Kian balance on a seesaw. Kyle's weight is 500 newtons. Kian's weight is 300 newtons. The seesaw is made of a uniform plank and weighs 800 newtons, which is 4 meters long, pivoted at its center. All right, so it pivoted at the center. So that's telling you a whole heap of stuff there. All right, let's see what the question goes on to ask and how much it valued. So by taking moments about the pivot, calculate the distance x that Kian must sit from the pivot to balance the plank if Kyle sits 1 meters from one end of the plank. So, all right, quite a bit for us to do here, but it's 4 marks. Now, guys, as I told you before, if you're getting something to calculate and you say it's a moments question, what's the first thing you're gonna do?
Write the formula.
Write the formula. Write the formula. That's it. Write the formula. As a matter of fact, I'll go as far to say write the formula and the principle of moments. Write those 2 because that potential is 2 out of these 4 marks. So I'm going to write down the formula because I am saying, well, if they want me to calculate something, I must use this formula. Whether or not I know how to use it properly is a different thing, but I'm writing it just the same. So here's the moments. So definition is moments is equal to force or weight. In this case, it's going to be weight times distance from pivot. We have to add that part from pivot. If we don't write the pivot from pivot, no, they will probably debate was as to whether to give it a mark here, but to be on the safe side, it's actually a perpendicular distance anyway. So the perpendicular distance from pivot. So if we let me see if I can bring up something that summarizes all of that for the visual learners here. So that is moments and let me see now. Yeah, there we go. Having something here. Well, this is what they have here, calculating moments. All right, so the same thing like what we have then. No big deal. This is can work then. All right, we can just simply write M is equal to F times D. All right, so same thing. All right. In this one now, they are not asking you, they notice calculate the distance. So we underline what the marks to calculate. So guess what? You can actually squeeze in a mark by writing what the distance will be. When you're using this triangle, let's go back to this triangle. Or in fact, let's even get another formula, another triangle in this. All right, so I see a nice one here. And I'm gonna paste it here. All right, there we go. Have you seen this? This is, so again, we're not the only ones using triangle. Other people out there using the same triangle here. All right, when you write this, you're gonna get 1 mark. But what will also seal the deal is that this is what you're going to find. Notice them said distance X. So this distance is what they want you to find. So which means you have to go know the moment, and you have to go know the force. All right, so identifying what them asking for is another good thing to do here. All right, so let's go. We are simplifying a question that look challenging, but it really is not that challenging once you get. So 1 mark is guaranteed here for what is there so far. All right, calculate the moments. No, here's the trick. No, I'm not working out anything just yet, and I'm going to get another mark because I'm going to write this this entire question. Looking at it, it is talking about the principle of moments. So one of the things you're going to write here without calculating, guys, remember, without calculating, even though the marks is we calculate and we still get enough of the marks them without calculating, you're going to say using the principle of moments. I can just even make this smaller too, because this take up too much space. All right, let's drop that there. Can we just move that? Yeah, so I'll just move this right there. I'm finding the distance right there. All right, so using the principle of moments. All right, using the principle of moments, we're going to say what? Clockwise. This is a mark, you know, clockwise moments. And in fact, sum of, by the way, sum of clockwise moments is equal to the sum of anti-clockwise moments. This is a mark, guys. This is a mark. 2 marks already, guys. 2 marks just like that. And it's potentially 2 marks because, well, we would have to probably go 1 little step further because since we say moments is this now, we have to go write the clockwise moment and anti-clockwise. So clockwise moments. So I already know how to find out moments already, right? Because the formula is there. So what you're gonna say now is force times distance. Very good. You're saying that there is equal to force times distance. So now this is where you set up yourself to get the 2 marks. Now you're showing CXC say you know what the question is about. The marker for your understanding or showing your understanding of the question. And you have done that so far. This is 2 marks already. If you can't bother work out anything or reason out anything else, well, fine, you'd have gotten half of the marks here already. But any questions here, guys? Does this look hard so far?
No, sir.
Well, no, you see what we're doing here is going back to the basics. All right. I know persons joined late and wasn't or seeing what we did before. But all we're doing before was looking at the definition for moment and stating the principle of moment. So whenever we see that word in the exam, is one thing them can ask you for, which is this. Them can ask you for the formula, or they can ask you for the principle, which is this. So when I would say, guys, if it's moments, it's formula and principle. All right. So know both of them. Know the formula. M equals F times D. And the principle. Clockwise moments equal to anti-clockwise moments. Bam. 2 marks just like that. But we're gonna get the rest of marks though. Just showing you where the start of it will be. So we have to go back to the diagram to get the other 2 marks now. Let's go to the diagram here and see what's happening. What we could do here is get creative. And just put in the numbers where we see Kian and Kyle here. So they've said Kyle is how much? Is 500, right? Kyle is 500.
Yes, sir.
And Kian is 300. All right, the pivot is here. So, all right, they said here that the plank, all of this is 4 meters, but them say Kyle sits 1 meter away from the end of the plank. So Kyle is actually 1 meter from here. So where is he? Entire plank at 8 and 1 meter away is here. So all right, so let's use common sense here. The distance right here, so from Kian rather, distance of Kian to the pivot, because them say the plank
2
is
meters.
is it 2? It's 4 meters long. So yeah, all right. Let's go and say 2 meters, they say. It's 4 meters long. So yeah, definitely Kian will be 2 meters. It's going to split into 2 halves. So what them do here, so now, and I like how them set the question here, because you could look at the diagram and see that they actually, what's happened there? You could actually look at the question and say, well, all right, we could say, well, oh, this is halfway between. So this is 1 meter. Let me actually show you. This arrow here, should I draw longer? This here gonna be 1 meter. And this here are gonna be 1 meter. Not drawn to scale though, but about that. All right, let's pick up the distance here. We're not concerned about any other distance but the distance from the pivot. So Kyle is actually 1 meter away from the pivot. Why we know that is that them say the plank is what? Is 4 meters long, and then the pivot is at the center. So at the center of 4 is what? No, 2. Yeah.
Yes,
So I'll be 2. So therefore, but them say he's 1 meter from the end of the plank. So we just take off the 1 away from the end, which this is giving me a little trouble here, but I'm going to remove these parts here. So we know that he's 1 meter away from the end, and there it is. All right, so we are almost there. Now let us identify the clockwise and anti-clockwise now. And I would say clockwise, follow the clock. Clock goes in this direction. All right, if you remember how the clock work, I don't think people have clocks anymore. They have them phone now. So, but they have clockwise is this direction, which means this direction is against the clock. This is what? Anti-clockwise. So identify this now is another thing. So the clockwise part is Kyle, anti-clockwise part is Kian. We have everything we need to know about Kian, right? Kian is on the anti-clockwise side. So this is a case where we know what is happening on one side. And with these questions, so what students forget is that for moments, you only need to know what is happening on one side. One side is equal to the other side. So therefore, if you know everything about one side, for example, the force of Kian, which is 300, according to the question, and the distance of Kian is what, 2, then we don't need to know anything over here except, well, the question asks for the distance. So we figure that out. I hope everybody is seeing what's happening here.
Yes, sir. I already see something with my hold on to right now, center too, sir.
Right. Good. So So we know the anti-clockwise side, we know Kian's side. The clockwise side now, which is Kyle's side. Again, clockwise will make it turn this way. So 500 times 1 meter. All right, here's the thing now. Them say calculate the distance x, which Kyle must sit in order for it to balance. All right, so right now it's not balanced now. You see that? Kyle up in the ear. And Kian is down on the
Yes, sir.
ground. Because what?
Because Kyle is closer to the pivot point, the center, sir.
Yes. So we are going to find that distance that he must be. So we're going to call that x. Them say find the distance x. So I call that x. The force of Kyle is 500. So Kyle is actually heavier. Yeah. Probably Kyle get more food. All those things. Maybe older. Possibilities are endless there. But we're almost there now, guys. 500 times x is equal to 300 times 2. So what is 300 times 2?
600.
Yeah. But see there, that's 600. So using the calculator, that's 600. Newton meters. 500 times x will give you partially the answer. And then now the x would be now equal to what? 600 Newton meters divided by the 500. I remember it's 500 Newtons, by the way, so that will cancel that. And then you have an easy thing to do here, right? You should get 1.2 as the answer. And so it should be 1.2 meters. And that's it. Any questions?
No, sir.
So guys, as we say, I'll show you how you can get the first 2 marks easily. Go into the exam and get in there confident. Once it's a moments question, them have to ask you about you have to use the formula and you have to know the principle of moments. Write those down. If you're having problems after that, don't worry yourself. Just know so you get them 2 marks already, and maybe leave that question and try and look for others now where you can get some more marks. And then when you get those marks, your confidence will get higher, the memory will get better in the exam, and you can come back to this and lock it down some more. So that's what it is. As I said, don't fight the exam, just work with the exam. You're going to start performing your best in the middle of the exam. As a couple of minutes after your brain, the first half hour after your brain gets settled, everybody quiet and exam run off now. You overcome this initial anxiety and then you get into a mode where you start work the paper now and then information start flow. That might not happen for the first question, but just believe in yourself, work through all the others, build your confidence, and anything where you leave out, you go back to it. No, that's the strategy, guys. So that's it, guys. A simple moments question here. So far, this is 4 marks. We'd have gotten 4 originally. The first part of the question, which was this. 4 marks to state the passage here. The principle of moment says that when a body is in equilibrium, the sum of the clockwise, in fact, we should have put in moments here. When they left out the moments, it's actually moments that should be here to complete the question. And the answer really. All right, some of the clockwise moments is equal about any point is equal to the sum of the anti-clockwise or counterclockwise moments about the same point. All right, that's 4 marks of information there. 4 and 4, 4 and 2 is 6, 6 and 4, 10. Some more marks is out there for us with this topic. Because here you go. And that's why they ask this 4 and 1, 5. So 15 marks in. So yeah, if balance, calculate the reaction force about the point, and that's 4 marks. So what is the reaction force at the pivot? And all right, so a lot of students know this again. this will carry us to the same principal moments though. Remember that the principal moment states two things. We said that the clockwise moment is equal to the sum of the anti-clockwise moments about the pivot. But what else does it say? I did mention that to you before. Let's go back to it. All right, it states two things. See it there? Principal moments for object to be in balance or in equilibrium. Two things must be happening. One is this one. This is the easy one. Clockwise moments equal anti-clockwise. But the second one is what?
The upward force is equal to the downward force.
Yep, that's 1 mark there now, guys. You get this into the question. That's 1 mark. All right, that's 1 mark. So let's go back to the question. And that's 1 mark. No, this is not. Oh, it's actually on the other mode. Oh, there you go. So just like how I just copy it out of the notes and put it right here in the question. That's how you can copy it out of your brain and write it down. All right, so that's it. That's it, you know. You get 1 mark for that, you know. 1 mark. Because reaction force at the pivot. What are they talking about here? Let's go back to the question. Let's look at what is happening with Kyle and Kian here. There is a force at the pivot here, guys. There because all of the plank is rest here. Kyle and Kian is on it. Kian is 300, Kyle is 800. The plank has a weight of 800. So Kyle and Kian plus the weight of the plank is actually here. So guess what's gonna happen now? These are 800. Let me even put this in a red. I don't know if you understand what's happening. 300 over here, so the whole plank weigh 800 Newton. Right, all of the weight of a uniform object is focused in the middle of the object. So all of the weight of the meter, of the plank rather, is here in the pivot. That's why the question asks you what is the normal reaction force. So this is so guys, as we say, one thing you must understand it in physics with forces, right? There for every action there's a equal and opposite reaction. So if a lot of force is acting downwards on an object, then the force will the object itself will react to that by opposite and equal force. So then 300 is downwards, guys. That's a downward force. All right, Kian is downward, Kyle is downward there. 5 and 3 are 8, and this 8. So what's the total force that's on the pivot? Kian plus the plank plus Kyle. How much is that?
1,100 Newtons, sir.
All right, very good, Lennox. 1,600 Newtons will be on the pivot. All right, that is the sum of the downward forces. So we are tearing this question apart. All right, sum of downward forces there would be why isn't this writing? Give me the option for draw. Oh, need to change it. All right, I'll go on. What's sense? Yeah, there we go. So Kyle and Kian. So downward forces will be all right, so we have 500 Newtons, that's for Kyle, plus the 800 Newtons, which is the plank, and plus Kian, which is 300. And that's the sum of the downward forces, right? Add up them. And then add up and we get 1,600 Newtons acting downward. So this so far is the 2 marks, looking as if it's 2 marks there. Any questions?
No, sir.
All right. So let's see, downward face. Okay. All right. Let us go back to the let's go a question here. Any other information I miss out? What is the reaction for it? That's the reaction to the 1800 there. All right, so look like 1 mark for the principle and then 1 mark for the answer there plus the units. Calculate the reaction force at the pivot. So using, all right, and of course using Newton's third law, third law, and action equal reaction. All right, action equals to reaction. Therefore, 1600 downwards is equal to 1600 newtons upwards. All right, and that seal the moment of the reaction force about the pivot. What is the moment? All right, so the reaction force about the pivot. That seemed to be asking about all right, the reaction force about the pivot. That is, oh, it looks like maybe Newton meters. All right, let's just put the Newton meters here. All right. It's 1 mark. All right, so that's pretty much it. We have we see what a moments question would look like potentially. We have moments and we look at Hooke's law before. So the video for that, those of you who didn't or who weren't at the last class, you know, the video for that is there. But here is our moments at least walk through here. All right, so we won't stop here for tonight, guys, because as we say, we say we're on a mission to, you know, knock off these topics here. We looked at 1 and 2 last class, and now we're actually at 3. So we finish look at 3 now. Yeah, as we say, guys, the takeaway from this one is to remember the definition for moments, the formula for moments, which is the same thing really, and the principle of moments, the 2 conditions that are required for an object to be in equilibrium. All right, that is what the third topic is all about. All right, any questions, guys?
No, sir.
All right, did you guys learn anything tonight?
Yes, sir.
See, if you remember. All right.
Yes, sir.
All right, so I don't know. This is something I think I should compile all of these in the group. Let me just drop off this. All right. Can I group this? Well, yes, I can group, yes. All right, drop it. I'm going to send this in the group now. So that will go all right, so the question we did. All right. And then I go, let me see now, I go forward. All right, if I go forward these to Linux and Tarika. All right. So that's it, guys. You saw that in the group. There's something else I should send as well.
Yes, sir.
Yeah, this part. Let me see another. All right, so copy that and send this. Let's run that. Send this now. All right, so you should be seeing that.
Yeah, space this.
So then how space override?
Just showing a computer is too knowledgeable for such mind set. You're gonna be like, why is
All right, so that's that. All right, so that's the past paper. This is the information. All right, let's send this to. All right, send that. Yeah, principal moments version. All right, so that's that. So that's it. All right, so you're supposed to get a few documents there. All right, guys. So I will keep you guys posted as to when we meet again, so we can finish up. Remember that the idea is that if we meet before next week Tuesday, that we should try to cover these topics here. I'll just go back to that page. We're going to cover 11 to 15. All right, 11 to 15. Topics 11 to 15. So let's keep you guys posted in terms of the timing for that one. All right, I'd even Saturday open for that one. All right, not sure what chemistry is going on with, but certainly need to meet for physics. So any questions, guys?
no, sir?
All right. Remember that your lab books, your labs are due. So Friday will be the cutoff point, which is tomorrow. So I've gotten from a few persons. So first I want to know on yourself. All right. All right, guys. So that's it. Thanks for being here tonight. And I guess I hope you learned something, and also please revise your information, right, so that you can remember it for next month. Don't revise it too near to the exam. The further away from the exam you try to study something, is better. So time right now is more precious. The time now is more precious than the time after. As you say, know, if you try to know it now, then when you decide to take it up later, no, it's going to be easier to remember it. So, but if you wait till then to take it up now, you're going basically, when you take it up that time, which is too near to exam, you're going to have a lot of mental stress there, and it's just not going to be the same. It's going to be a lot harder. So, guys, as we say, go through your notes. Try and find a book or a source that deals with each of these topics. And we have notes that I give you on these topics. Focus on those really, because that will hold some information that CXC will ask you about. So as we say, guys, just remember, pay each topic some attention. You probably can read up on alternating current. All right. If you take up most books, the language of most textbooks might not be the you might not understand everything, but do what I do when I work in questions with you guys. I underline things that I know and piece them together. So that's one way you can use. But alternating current and resistance, yeah, that's the next thing we're going to look at. So guys, until then, stay safe, and I will see you whenever.